Welcome to the audio recording for our lecture on cloth and lumber. If you're following along numerically, this is lecture number 14. Today, as always, I want you to write down your learning goals as we go and make sure you're taking notes associated with these learning goals. And this lecture, it looks like we have a lot of extra learning goals here because I've got a very dense first slide, but there'll only be two parts to this lecture. So these 5 goals actually comprise everything to do with cloth, and then you'll have another 5 goals for everything to do with lumber. So it's actually not that long, so don't get intimidated. All right, first, our learning goals. We are going to describe thread, which you're used to thinking of, threads. Okay, you've seen threads that go through needles. We're going to describe them as a bundle of twisted cellulose fibers. So they're actually plant fibers. And then I also want you to think of fabric as a meshwork of these threads. Next, we're going to list major events by date associated with cotton use and cultivation in both the Americas and Asia. So similar to how coffee was grown in 2 locations, we're going to see 2 major locations of cotton use, but unlike coffee, we're not going to have to move the cotton from one specific location to others. Cotton actually grew in multiple locations on the globe to start with. Then we're going to describe the biology and classification of the cotton plant. And just like before, we're going to use some terms from previous lectures. We're going to talk about the classification of it. We're going to fit it in with our other knowledge and our ever-growing web of plants. We're going to talk about flax as one alternate source of threads for from plant-based material. We're going to talk about how it differs than cotton. What's a big difference between where the threads come from and the plant itself, and how you process it. And finally, of course, we'll then do biology and classification of flax and tie all of this information about plant use to the actual plant biology behind it. All right, let's talk about thread and cloth. Now, a lot of people don't see the connection between the threads they're used to putting between a sewing needle and cloth that you're wearing right now. So the way I want you to think about this is cloth uses finer threads, smaller ones than what you're used to thinking of for going through a needle. Okay, so if you're sewing with a needle and thread, that's a pretty thick thread. In fact, it's several threads wound together. Cloth, I want you to think of as a little bit thinner, and I want you to think of it as an up and down, back and forth woven structure. If you think about how a plant, like a reed basket, is woven, that's the exact same way we make cloth. We're just taking strings and going up and down and up and down and up and down as we go under, over, under, over, under, over, a long line, loom full of threads going one direction. You're weaving another thread going crosswise through it. Okay, so that's what fabric is. So now we need to talk about what's a thread made of. Threads, and you can see a nice little picture in the lower right hand corner, all they are is twisted plant fibers. Okay, and the way that they stay together is because of the twist. By twisting them up and then kind of wrapping them in the opposite direction of their twist creates a lot of tension on the fibers and creates lots of friction. And for the fibers to let go of each other, the thread would have to untwist. But as long as you've locked both ends of the thread in place, it can't unravel. It can't untwist. Okay, so that's how thread gets put together. So we said it was made of twisted plant fibers. What are we talking about when we say fibers? We're talking about strings of cellulose. Okay, and most plant fibers that we're going to use for cloth and thread are going to be between 1 and 3 centimeters long. 3 centimeters is some of the longest you get out of cotton, which is pretty dang long. 1 centimeter is more about what you get from the shorter varieties of cotton, and also you get more from flax. Okay, so we'll discuss cotton, and then we'll also talk about how flax fibers are used to create a kind of cloth that you know as linen, which literally is what we think of when we think originally of bed sheets. We still call them linens, even though they're made of cloth. They're made of cotton now. They still maintain that name, linen. Okay. Now, let's talk about the history of cotton in the Old World. Okay. India is basically the place where cotton first got off the ground and first started being made as a cloth. And we're talking about at least 5,000 years ago. So we can find evidence that's as old as 5,000 years ago of cotton cloth. That doesn't mean that's exactly when it started. That means it's at least that old. Fast forward, so 5,000 years ago would be around 3,000 BC. Okay. Fast forward to only 1,000 years ago. Okay, so that's the turn of the last millennium, 1000 AD. Cotton cloth is being used a lot by Arabic countries, and so it's a primarily Muslim industry. Okay, and that's particularly interesting because there's a kind of fabric called muslin that still exists, and we still use it, and it's made from very fine cotton. But even more interesting than that, I believe, is the root of the word cotton. It comes from katan, okay, which is, I don't even know if I'm pronouncing that correctly, which is the Arabic word for the plant. Okay, so even its name comes from its Arabic roots, in the India and Arabic Peninsula. All right, now cotton cloth, Europeans knew about it, but they didn't use it until the 1800s and later as their primary form of cloth, because there wasn't a big export market for it yet. We'll learn why the U.S. started to suddenly export cotton in the 1800s. Up until then, they were using primarily linen, which they could grow locally, that flaxseed, and then, of course, also wool. They were using animal fibers. Now, if we're talking about the New World, suddenly we realize that cotton got its start, according to all mankind, in Peru, in South America. So our oldest evidence of harvesting the cotton was at least 10,000 years old in Peru. And by 5,000 years ago, not only were they making the cloth, but they had already domesticated the plant. Now, it's funny to note that two of the best varieties of cotton, we talk about Egyptian cotton. What's entertaining about that is the variety of cotton that is called Egyptian cotton originated in Peru. And that's why it's also called Pima cotton. Pima is a place in Peru. Okay, so the name can be misleading, just like Arabica coffee that originated in Ethiopia and was grown on the Arabian Peninsula. Most of the Arabica coffee you drink is actually grown in South America, right? Egyptian cotton is originally a South American cotton that was moved. All right, so we're talking the old history of cotton in the New World. Now let's talk about more modern history. When cotton moved to the North American colonies, that happened starting in the 1600s with Virginia. Okay, the southern colonies hadn't quite taken hold yet. Virginia was a good one for that, but you don't quite have Georgia off the ground yet, and there's certainly not a lot of people in it. So you don't have the large-scale cotton business that we're going to start to think of in middle Georgia and Alabama and Mississippi. That hasn't taken off yet. It's going to start first in Virginia. But I mean, that doesn't really matter to this. It's the only idea, the key to this is that it's the 1600s. Now, for the next 200 years, cotton didn't become that big of a deal. Okay, and the reason why was that cotton was very labor intensive. Okay, because if you look in the lower right-hand corner now, you'll see that when you pull cotton, you're pulling off a product of a seed. So the cotton fruit we're going to learn about pops out all these seeds with the cotton fibers attached. And so you got to get rid of the seeds. And that process is called ginning. Okay? And prior to 1800, you basically had two metal combs, one attached to each hand, and you just scraped and scraped and scraped at the cotton until the seeds fell out. You could spend a whole day doing this, and you'd get about 1 pound of cotton. So that meant it was not a great agricultural product for its labor. Now, it was super soft and was highly sought after, but U.S. production prior to the 1800s, it was a lot. It was 156,000 bales, but that's not like a full industry yet. That's more of a cottage industry at this point. And the South was still focused on more like things like corn and other products that could be turned into whiskey. Okay. Now, coming close to 1800, okay, so 1790, Eli Whitney invents a machine that can gin the cotton much faster than a person can do so by hand. And since this is 1790, I'm going to bet that it still took a person to run it. A person was probably hand cranking it or pedaling it. Okay, but at the same time, around 1800, these machines start getting so popular that now you've got each individual person plus one machine harvesting or preparing 50 pounds of cotton a day instead of 1 pound of cotton. And even though your cost for the machine was also high, the cost to maintain a machine is much lower than the cost to maintain a person. So this is the time when slavery really took off in the South as an enormous industry. And your production of cotton rose fivefold over the next 30 years. which is a radical rise in production. And slavery also increased at about the same rate because now you could have many more slaves employed picking the cotton, with many fewer slaves having to also sit down and gin it. Okay, so that's a little bit of history for you there, and that's that one little fact, and the introduction of a mechanical cotton gin, it had a radical impact on U.S. history for the next 100 years in the South. Okay, so let's get into the biology of cotton. I like it because it's gossypium. It's like you're gossiping. Okay, all of our cotton plants, and there's multiple different species of cotton, some of which have been hybridized with each other and bred together and blah, blah, blah. There's about like 30 different species out there. So instead of trying to learn a species name, we're just going to focus on the genus they all belong to. So that's Gossypium. What do we know about these guys? Well, first off, they're dicots. All right. Well, that means that they are in Magnoliophyta. Okay, so they're flowering. They're angiosperms. They're dicots, and the group they fall into, because I love to split those dicots up into the rosids and the asterids. Well, cotton's going to fall in the rosid group. And specifically, we'll learn that it falls in those malvids, which means it's closely related to mustard and citrus. Now, to continue using terms from previous lectures, remember dehiscent fruits? Those are the ones that burst open to release their seeds. Okay, and pretty much all dehiscent fruits are dry. So cotton, as you can see in the lower right-hand corner there, cotton is making a dry dehiscent fruit, the bowl of it. This is called a cotton bowl. Okay, but it's just another way of saying burst open cotton fruit. It naturally releases out all these seeds that have these long white fibers attached. And the way it works is once this thing bursts and fully dries, the seeds are actually going to blow away using those long strings in much the same manner that spiders, little baby spiders, can release a long string of silk and it will blow them away. Same thing with these cotton threads attached to, you've got between 10 and 50 seeds in here depending on the species. Okay. Last thing we'll talk about, cotton, if you're in the tropics, is perennial, which is good. That's better for agriculture if you can use a perennial crop, because that means less tilling, okay, and less having to re-prepare the soil every time, which makes the soil last longer. But in temperate regions like the U.S., it's an annual crop, so you have to completely cut apart the bushes after you harvest your cotton, okay, and then you have to till the soil up again, and so that's rough on the soil and increases your need for fertilizers. It increases erosion, all those things that we learned about in previous lectures. I told you that that cotton was a dicot, and so I want to focus you on this spot on our tree before. So from our herb lecture, you remember that we had the mustard plant, which was the predecessor of like broccoli and Brussels sprouts and cauliflower and all these guys up here. But also your citrus trees were in the same group called the malvids, okay, inside the rosids. Well, so cotton is going to land inside the rosids there, near mustard and citrus. So you're going to need to know, you're going to need to answer some questions like who's closely related to cotton, right? Because that's one of our goals. And down here you can see the cotton flower, which I know you don't think of very often. When you think of cotton, maybe you think of a field that looks like this, because we live in Georgia. You've probably driven by a cotton field that's been picked, particularly in Middle West Georgia. Okay, if you're heading towards Alabama, you're going to see some cotton fields. What you don't usually think of is the cotton flower. But all these things that we've been talking about for the past 3 lectures, they're all flowering plants. And so, remember, they're pretty too. Okay, so you can be like, wait a minute. Up until the 1800s, Europe didn't have cotton, but you're pretty sure they wore clothes. Okay, and so I want to bring into your mind the idea of flax. Okay, so the flax plant likes to grow in Europe. It can grow all the way up in Ireland. Okay, it's a tough, reedy plant, but it can also grow all the way down in Bangladesh. So flax is a great source of fibers because it's not as picky about its environment. Okay, now what do we see as different from this? Well, instead of pulling off seeds and fruits, the flax fibers actually come from inside the stalk. Okay, so rather than picking something that's at the tip of the plant, we are going to rip up the whole plant itself. And since the stalk is covered in harder elements that are not so soft, we've got to find a way to separate the stalk from the cellulose fibers, the pure cellulose fibers inside it. And when you do that by letting it rot. Okay, so the original processing and really even modern processing involves letting the fibers lay in a wet field, or more advanced methods are you put it in a tank of warm water. The process is called retting, which is just I don't remember which language that comes from, but it's the word rotting. Okay, I think it's Scandinavian, I think, something like that. I don't know. Go look it up yourself. But in any case, it's a much lower labor intensivity to separate it, because you just let it rot for a few weeks, at your leisure. You cut down the field or you rip up the field, just lay it right there, let it rain on it. Come back in 6 weeks when you feel like it, and then you start pounding these stalks basically with a flat your shovel or mallet type thing, and the harder parts crack open and the softer parts are released from the rest of the stalk, and you can just strip them right out. Okay, so now it comes time to talk about flax. Okay, what is it? Let's talk about its biology. And down here you can see these women are retting flax stalks in an open field. Okay, and this is in Bangladesh. Okay, so linum. All right, now you get the idea. The linen fiber comes from the genus Linum, and once again you have multiple species here. But these are all also dicots, and they are also rosids. But they're going to come from the second half of the rosids. They're going to come from the falvids, the apple side, the apple tree side of it. Okay. Additional biology we want to learn. Now let's talk about those fibers. Where do they come from? Instead of being individual fibers of cellulose used as a weird kind of kite, these fibers are coming from the phloem cells. So these are wrapping the phloem cells just below the bark. Okay, so this is probably the result of primary growth, right? And these phloem have thinner cell walls, so they're made of cellulose, pure cellulose, rather than lignin. All right, and from a farming perspective, this is an annual plant, even though there are some perennial plants and some versions of this that could be perennial. The way you harvest it is generally ripping it straight out of the ground so that you have that nice, long, pretty stalk. You get your maximum length of fibers. So even if you're planting a perennial version, you're still going to be ripping it up so it can't grow next year. So this is going to require all that tilling and the greater erosion that's going to come from it. All right, so here's our final picture of the relationships for today. The Malvids versus the Fabids. Okay, you've got cotton and flax as close relatives of each other, making these pretty pure strands of cellulose. Another thing you might be thinking of, you may have heard of flaxseed muffins, or you might have heard of flax oil, or even the term linseed oil. All of these come from slightly different versions of flax that have bigger seeds. It's that same Linum genus, but it's a different species that we plant. And flaxseed used to primarily be used as an animal feed. Okay, so they would, different varieties of flax would be grown near each other, some for harvesting the seeds, other for making cloth. But the flaxseed only recently has really gained popularity as a food supplement because of its perceived health benefits. It's one of those whole grains. It's got more nutrients in it. Linseed oil, by the way, is also a big production, that flaxseed oil. It's used in a lot of finishes for wood and furniture, and is also considered an essential oil in holistic medicine. All right, so that's enough about cloth and cotton. Oh, by the way, you may have heard of cottonseed oil as well. If you ever wondered what they did with all those cotton seeds, now you know. We use leftover things for everything. All right. Here's the second half of our lecture, and here we're going to be talking about wood. And we're going to talk about what hardwood and softwood are, and we're going to focus on their density and their use. And while we're at it, we're even going to talk about what wood itself is. Then we're going to focus on the biology and classification of what makes a hardwood or a softwood wood, So we're going to be using terms, like gymnosperm and angiosperm, and we're going to be talking about things like sclerenchyma and all those wonderful words you loved so much when we covered them in the first half of the semester. Then we're going to jump away from wood, and we're going to take more of a I don't know, environmental perspective. It's almost like this is an environmental science course, And we are going to talk about the trends in deforestation, but also in reforestation over the past 40 years, because both are happening, and they're happening at different rates. Then we're going to compare arguments about deforestation in the tropics. I'm going to bounce you back and forth a little bit there. I'm warning you now, but you'll forget it by then. And then we'll talk about mahogany and mahogany trees to explain how, though it's become popular to just say the words sustainable agriculture as if it's an easy thing to do, we're going to use mahogany as an example of how hard it is and how, once again, you're going to have competing aims. Just like with the agriculture, sun-grown coffee versus shade-grown coffee, there were competing aims at work there. There will be similar competing aims with mahogany. All right. Now, if you stop taking notes somewhere along the line, I know I'm fascinating and you're just staring at it with rapt attention, but I need you to get back to your note taking because here we have some very, digital information. So let's talk about softwood and hardwood. First thing to note, softwoods are going to grow faster and they are cheaper to harvest, to cut down. They're cheaper to mill, and we're going to find out they tend to grow denser per acre than your hardwoods because they make nice straight trunks. So you can get a lot of boards out of softwood. Okay, so these are what we use primarily for construction. But we also like using it for paper. Any trunks that can't be used for construction are sent to paper mills. And so that's about 50% of your softwood that's cut down is sent to paper mills. If we're going to talk about the density of water, we use water as kind of our starting point for density, since one of the first things we care about is, does a thing sink or float? All right. So if the density of water is 1, which it is, that's something called specific gravity. The density of softwood is approximately half that. Okay. And so it definitely floats. Okay. So most woods will float when you drop them in water. Softwood floats pretty high in the water. Hardwood, on the other hand, has a density of somewhere around 0.6. It still floats, but you'd see less of the log sticking out of the water. And if you lifted a board of hardwood that was the same size as a board of softwood, you'd find the hardwood weighed about 50% more. Okay, so this stuff grows slower. It's more expensive, to harvest, to mill. It's more expensive to transport because it's heavier. A lot of things about it are more expensive. Okay, so what do we use it for? Well, we use it in places where strength is important, but space is limited. Okay, so that's one of the reasons why furniture is primarily made out of hardwoods as opposed to softwoods. To get the same kind of strength out of a chair leg, you'd need a much wider chair leg or table leg. Also, pine doesn't carve as pretty as hardwoods, so our softwoods are not going to conform to attempts to make elaborate shapes. They're going to work much better as straight boards. Okay. Additionally, we use hardwoods for flooring because they stand up to wear a lot better than the softwoods. Softwoods dent and scrape easier. The hardwoods can kind of fight back. That's particularly when you're coming into the idea of coming off of the heel of a shoe before the invention of rubber. But even now, if you're talking about a woman's high-heeled shoe, it's a very hard strike on the floor, and also pet nails. They tend to gouge the floor, so you need hardwoods rather than softwoods. Okay. Now, this is just kind of an example. You don't have to take notes on this. This just lays out for you differences between hard and softwood uses. Okay. So things like walnut, and mahogany are often used to make expensive furniture because they are naturally very dark. And we don't like our furniture to be light colored. If you're going to have light colored furniture, you tend to just go ahead and paint it white. Okay. But mahogany and black walnut, the moment you just rub them with any sort of oil, they just take on this beautiful, dark, luscious texture. But also they're very hard, so you can make furniture out of them. Whereas if you're talking about white pine, you're talking about outdoor construction. Douglas fir can also be used in outdoor construction, but it's also really good at building boats because it's very light. Okay. You know, you've got spruce, redwood, all these softwoods. You're not building your house out of them. Or excuse me, you're not building furniture out of them. A violin is not known for its strength, right? Compared to mahogany, okay, or oak, like we use up here, oak. You know what we love? Doors made out of oak, even if the rest of the house is made out of pine, because you can use a lighter weight, thinner plank of oak and still have strength. So all the ones highlighted in blue are examples of softwoods. And you might be starting to see a pattern there as to which things count as softwoods and which things count as hardwoods. I'll give you a hint. Gymnosperm, 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 okay, it's the gymnosperms are going to fall into softwoods. A little precursor. One more note, let's talk about wood, and let's talk about the biology of wood. This picture right here is a crosscut of a tree. So it's like we cut a disc out of a tree. And so you can see all those rings of alternating xylem, okay? Whereas out here you have your phloem and your vascular cambium and your cork cambium, right? So this whiter portion out here is your living tissues. These darker rings on the inside are your dead xylem, okay? So when you're talking about creating a board, for example, out of a tree, what you're doing is you're cutting up all this secondary xylem into flat rectangles. Now you don't cross-cut it like you do here, otherwise your boards would have all these rings on them, right? You'd see circles when you look down at the board. What you do is you lengthwise cut it. So imagine a board sticking out of the screen at you, long ways, like a board was stripped out of the length of a trunk, okay? So we cut them lengthwise out. And then this brings up the idea of the grain of the wood. When you cut boards that way, not only obviously can you make them very long because trees are tall, so you can make a very long board, but if you were to cut it straight across the trunk, your board would like only be a couple feet long. Okay. Not only can you make a very long board, it causes a grain to appear in the board, which is the direction of all those tubes of xylem. Okay. So that means the grain runs lengthwise along the long distance of the board, and that gives you a very strong object so that you can stand in the center of a board supported on two edges, and the xylem resists the breaking. Okay. Whereas if we were to make a board out of these circular cuts up here, if somehow we had a board, like a really tall tree that we just cut a board this direction out of, and it was like, somehow an 8-foot board cut this way, if you stood in the center, it would break because you're not standing crossways to the grain. You're standing, you're standing on the grain, and it would just shatter in that direction. So that's something important. Cutting a board that the long dimension follows those xylem is a way in which our use of wood matches the biology of the wood. Here's another place. You've all seen a knot in a board. And if you haven't, go to Home Depot, grab a pine or any kind of board, and try to find one that doesn't have dark circles like here and here, or even a chunk taken out of it. This is what a knot looks like inside a tree. And what you need to know about knots is they're either places where the tree was wounded, which is one thing that can happen, or they're places where the branches either attached or used to attach. A branch attachment isn't just glued to the bark. It digs deeper in. It's got kind of a, its own structure that it puts into the side of the tree. And particularly, knots that are near, deeper into a tree represent spots when the tree was young and it had a branch at that height. Okay, but as the tree got taller, it didn't need the branch anymore. So the secondary growth, as the tree got wider, kind of swallowed up the spot where the branch used to be, and that results in a knot closer to the center. Okay. By the way, you can always tell which portion of a tree the board came from. If it's cut near one of the edges, you'll see these swoopy lines cut across it. If you've cut your board from out of like this rectangle, right, that is extending way up top. But if you cut your board more out of the center, you get the center cut, looks without the swoopy edges. Okay. Also, there's a thing called radial cutting, which basically keeps cutting the boards at this angle. Okay, so it's like a fan of boards going all the way around. And also gives you that center cut look. I won't test you on that, but that's just a neat thing to look at there. Now, let's dig into the softwoods and what makes them soft. Coniferophyta, all of your conifers, Okay, so the bulk of the gymnosperms, they are considered softwoods. Okay, not all of them are actually soft. There's some overlap between conifers and their density and some of the angiosperms we'll talk about later and their density, because so there's some very soft angiosperms and some very hard conifers. But the way we use it generally is just talking about the whole genus itself. I mean the phylum itself. Okay, so it's a general trend. In the conifers, you tend to find that the xylem in conifers, which is where your wood comes from, are made out of tracheids, which are the thinner elements when you're talking about xylem. Okay, we'll remind you of the name of the thicker xylem elements later. But the key to this is that they have less lignin in their cell walls. So they have less lignin, more cellulose. Okay, and remember cellulose makes soft fibers, right? So that's not as strong. Okay, and so the xylem are not as strong. Also in the boards, you will find more collenchyma and less sclerenchyma. So remember, collenchyma and parenchyma are softer tissues. Sclerenchyma was the super hard lignin-bearing tissues. Okay, so we didn't have much of that. Sclerenchyma was also the gritty stuff in pears, and the surfaces of seeds were made out of primarily sclerenchyma, hard and woody. Your most common versions of softwoods that are made into boards, pine trees, fir trees, spruce trees. You might think of them as growing kind of small, and a big one being like 7 or 8 feet tall, but that's just a Christmas tree we're talking about. When you're cutting down a pine or fir or spruce that's been growing for the past 10 years, they get pretty dang tall, and they love to put most of their weight into their trunk with relatively short branches. What you don't see in conifers is you don't see the trunk split into other huge branching trunks. Okay, it's got one solid trunk going all the way up, and that is just perfect for making boards. So that's another reason why we like using these guys for construction. Okay, it's another thing that makes them cheaper for construction, and per acre, you can get a lot more trunks when you cut down an acre of pine trees than you would get if you cut down an acre of hardwoods. Okay, hardwoods are from phylum Magnolia phyta. Okay, and we know that's synonymous with calling it an angiosperm, a flowering plant. Okay, these guys are considered hardwoods, and notice two different features. They like to bush out as they get taller, whereas your pine trees go more straight up. Okay, something that you have to do if you're going to do this, if you're going to branch out and have these heavier branches sticking out sideways to gravity, you've got to make them stronger. So your xylem are made from these thicker things called vessel elements. Okay, the tracheids are one kind of xylem we talked about. Vessel elements are the bigger ones, and they have more lignin. And then they're also supported by more of those sclerenchyma fibers. Okay, so both of these things make for stronger limbs that can jut out sideways. They can be thicker when they go parallel to the ground as opposed to straight up. And so that's why it's a stronger wood. Woods like oak, maple, mahogany, walnut, these are all your furniture woods. Okay, these are all your more expensive woods. And there's several reasons for that expense as I've laid it out. It's the fewer trunks per acre. It's harder to saw them down. It's harder to cut them into boards. They take longer to grow. All of that stuff. So speaking of cutting down trees, let's talk deforestation. Yay! Happy topic, right? Here's our environmental angle for this. Okay, first let's define it. Deforestation isn't just cutting down trees. There are plenty of managed logging forests in the United States that don't count as deforestation, because the moment they cut down the trees, they immediately replant the trees, and 20 years later, there's a forest standing there again. And so it's just kind of cycling that forest. Okay, so that's not what I'm talking about. I'm talking about cutting down trees and not replanting them. And you might be surprised at the number one or the top 3 reasons. A lot of people think that, because in the United States and basically where people live in the United States, 90% of us don't live near farmland. 90% of us live in the city. Okay, and so when we think of deforestation, we think of building a suburb. We think of you're cutting down trees to build, to build either condos or a parking lot or a neighborhood. And that is not, in fact, a major source of deforestation. It's just your observational bias, because that's probably most of the deforestation you've ever seen. It's clearing the way for the next strip mall. Okay. globally, your major cause is agriculture and cattle grazing. Those are the number one and number two causes of deforestation. You're either cutting down trees to create cropland that people are immediately going to till and plant and sow and reap, and we're going to have food or other agricultural products. Or they're cutting down the trees and they're just going to plant grass and wheat and buckwheat and just all sorts of tough grains so that you can then bring your cattle along them and give your cattle some food. Okay? So, cattle grazing and agriculture are your top causes of deforestation. Okay? And another cause, a third cause, a competing cause, is the cutting down trees to make boards and to make paper. Now, deforestation for boards and paper has slowed way down, particularly the ones for boards, okay, because a lot of your boards are coming from Canada and the United States, and there we're doing managed agriculture where we're not permanently deforesting. We cut down, replant immediately, and even selective cutting where they don't cut every single tree down. They cut like 2 out of every 3 so that you still have a whole bunch of trees left. And then so that your forest naturally regrows, okay, so you don't lose all your wildlife. So there's all different sorts of things. We can do that because we're rich. And do we need to? Okay, because you saw deforestation, cutting down trees bad. They paved paradise and put up a parking lot. There's songs about it, all sorts of things. But reforestation is actually happening faster than deforestation. Okay, so this is either happening from natural expansion of a forest. So forests can grow into fields, and each year the forest expands. Or it's deliberate replanting of forest by humans. So if a farmer is farming a field next to a forest, and then he stops farming it and stops cultivating it, okay, because he moves on to do something else, well, that field will generally regrow and reforest itself over time. But also, we've been trying to reclaim a lot of forest, and you have these things like the Billion Trees Initiative was something that you probably didn't hear much about because it was done in around 2000. So that was the idea of let's plant 1 billion trees, and they finished somewhere around these like 14 billion mark. So obviously 1 billion was too small. Recently, the United States has signed on to the Trillion Tree project, which is the expansion of this project. The Billion Tree project, by the way, got the woman who headed it up a Nobel Peace Prize. The Trillion Tree project is an even bigger one, trying to reforest more. Okay, so if we do the math on this, in the past 40 years or so talking about since 1980, deforestation occurred on average of 50,000 square miles per year. Okay, that's really big. If you want to know that number in acres, multiply it by 640, and then that suddenly seems even more impressive. Okay, but 50,000 square miles per year getting deforested. But at the same time, reforestation is occurring at a rate of 75,000 square miles per year. So net, we're actually gaining trees, not losing them. And about half of that is due to human decisions, like humans not doing as much widespread agriculture and kind of focusing it more in places that where there's already cleared land. But then also climate change seems to be affecting that somewhat. And, the increased amount of CO2 in the air, plus the warmer climates that are showing up in some of our more temperate zones. You add a degree or two to a temperate zone, and you triple the amount of CO2 in the air, and you see, the bigger plants start taking off. They really like it. Okay. So since 1980, we have increased our tree cover on the planet by 7%. So we're actually going in a good direction there. So yay us! Problem solved. Oh wait, not problem solved. See, deforestation is not just about percent tree cover on the planet. Okay, it's not just about number of square miles per year. It's also about where it is. The deforestation is primarily in the tropics. This is a place where you have a poorer population that primarily relies on agriculture for their money, and tropical soil, because there's so much rain there, is highly eroded soil, so there's not many nutrients in it. So the poorer soil gets exhausted, And one of the things that exhausts it is tilling and doing agriculture like that, right? Okay, you till under your soil, you lose some of the nutrients, you get even more erosion. Okay, and so you do all of this agriculture, and then in a few years, your land is exhausted. And since you're in one of these poor tropical countries, because what we're talking about here is Central America and the northern half of South America, or you're talking about dead through the center of Africa. That's not that's a place that doesn't have a lot of money, so you're not going to have a lot of industry, and you don't have a lot of chemicals. So you can't spray fertilizer. So that chemical fertilizer that we talked about several lectures ago, that's not there for you. So your soil is exhausted. Now you got to cut down more trees to get fresh land so that you can grow more because your previous fields are exhausted. Okay, and this brings into the idea that whole balance between sun coffee and shade coffee. Remember, there were reasons to do shade coffee. It was good for the environment, but it wasn't as economical. So that was a reason to do sun coffee, was because you need the money. Similar problems happen with other crops in the tropics. Okay. Reforestation, where is that happening? Well, it's happening in rich places and those temperate latitudes. Okay. Temperate latitudes tend to have much more industry, much less agriculture, okay, and higher population densities, so they're richer. Okay, so they can afford to do things like sustainable managed tree logging and things like that. Okay, further, if a percentage of regrowth of forests is also coming from warmer climates, the tropics did not get any warmer, and if they did, the trees wouldn't care because it's already plenty warm down there. But the temperate zones, okay, places like Canada, have gotten a degree or two warmer over the past, I'll go with 60, 80 years. Gotten a degree or two warmer. It's much more noticeable the closer you get to the pole, so that's going to cause greater plant growth in those areas. All right. So, deforestation in the tropics, reforestation up the temperate latitudes. This is not equal. Okay, so you have 100. You can reforest 100 square miles of temperate forest, and you have not protected as much diversity as you would find in just 1 square mile of rainforest. Okay, or said the other way, you could cut down 100 square miles of temperate forests and do about as much damage as you do when you cut down 1 square mile of rainforest. All right, so that means that we really need to work on coming up with sustainable agricultural practices and sustainable logging, and that's become a big deal. Google searches, I like to use Google searches sometimes to show about popularity of ideas. Okay, if you type in sustainable logging, you're going to grab 18 million hits right now. If you add the word tropics to it, it only cuts the number by half. So most of the focus on sustainable logging is focused on the tropics because that's the place. We've got some sustainable logging going on in the temperate zones. It's the tropical zones that have the biggest impact. Okay, so I left off the end quote for this, but just to be clear, sustainable, if you take it down to what it really means, what you're meaning when you say sustainable in an industry is you mean make less money, but you keep the natural resource going longer. So the idea of sustainable logging would be replanting the forest. But it's harder to replant a rainforest than it is to replant a deciduous forest. A rainforest would have hundreds of species growing in the area. A deciduous forest up here in the temperate zones has tens of plant species. So you could replant 10 to 20 plant species and get the whole deciduous forest back. But you want to replant a jungle? That's hard. Okay. Also, I did a search on news stories because seeing what the news is focusing on also tells you what people are focusing on. And it's hard to tell which one's the chicken and which one's the egg there. Do we focus on it because the news is telling us? Or does the news start telling us because we are more interested? It's chicken and egg. It's a cycle. All right, so I don't really know the answer to that, but I do know that between 2018 and 2019, number of news stories about sustainable logging in the tropics tripled. If you just put in the words logging, you find out you don't actually get an increase in number of stories between 2018 and 2019. But you talk about sustainable logging, tropics, Okay, you triple the number. It went from like 10,000 hits in 2018 to 34,000 hits in 2019. So it's a big recent increase in this concept. It's also one word or one pair of words used to indicate a massively complex problem. We love throwing the word sustainable, up here in Western world, okay, up here in rich land, we like to talk about sustainable. We want to use sustainable coffee, and things like that, like it's easy to do. Okay, but I'm going to use an example of how it can be very hard to be sustainable, especially when you're talking about farming in the tropics. So let's talk about mahogany trees. Okay, one of my favorite lines from The Hunger Games is when Katniss stabs a knife right next to, I think his name is Hamish, Woody Harrelson's hand, and the lady that's their escort goes, "That table's mahogany." She's not sad that Katniss tried to stab a person. She's sad that Katniss marred up an extremely expensive, beautiful table. Okay, so mahogany is a very valued wood, and it grows in, I think it's mostly South Mexico and also your Central American rainforests. Okay, it's kind of the northern half of it. So we're in rainforest territory, and mahogany naturally grows, so it's there to be harvested, but they don't grow very densely. Okay, you only get a few trees per acre of rainforest. So you're going to be taking up quite a wide area. If we talk about logging mahogany, it's not a small place. Okay, like when you log pine trees where it's just all pine, 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 pine. Okay. So when you get done cutting out the mahogany trees, if you want to come back and replant them, you can't. You can't replant them in the shade because the saplings won't grow. Mahogany is supposed to take root early in the spread of a forest and grow above all the rest of the trees. So it can't grow in the shade. So if you want to replant the mahogany, you have to take the forest down to the ground. And then you can replant the mahogany, but now you've disrupted the ecosystem much greater than just cutting down mahogany trees here and there. So what would sustainable harvesting of mahogany even look like? Okay, these trees take a long time to grow. You have to grow them in the open. You have to choose between disturbing the jungle massively and then regrowing it with mahogany present, or disturbing the jungle less but taking an entire species out of the ecosystem. So which one are you going to do? So this is making clear the fact that it's not so easy to just slap the word sustainable on things. Okay, it's actually a very complex problem. If people could do it easily, they would. People know about this. So be careful as you judge people, and you judge people in other countries who have much less money available to them, who get paid a lot less per hour. Be careful how you judge them and the agricultural products they produce. And then be careful how you judge people who use quote-unquote unsustainable things. Because even though it's cheaper for them, it's also producing more cash for the people in these poorer countries that are producing them. So you see, it's a very complicated balancing game, just like when we talk about agriculture and we talk about using, annuals versus perennials, high yield crops requiring more chemical fertilizers, GMO bad, GMO good. All of that stuff ties in the same way when we talk about sustainable harvesting. It's all about competing aims. Now, I just played a game with you. I just played a game called Fact versus Interpretation. I gave you lots of facts, and I gave them to you truthfully. But what I did was I kept giving them to you in a way that would flip your interpretation back and forth and back and forth and back and forth. Okay? So, did you feel it? Did you feel your opinion on deforestation, and then sustainable, unsustainable, good deforestation, bad deforestation, are we winning, are we losing? Did you feel yourself flipping back and forth based on which slide you were on? Okay? Because that's based on which thing I said last. And I've got this nice convincing demeanor, and I'm using these words, and you're used to listening to me, and you trust me. I'm your teacher. So if you go back and look at it, your opinion is entirely right now on this subject. Your opinion is actually set primarily based on the fact that I ended on the idea that it's complex and you shouldn't judge. So I've ended you in a middle opinion, even if you started or at any point during the process had an extreme opinion. Okay. Do you feel like you're seeing the complete picture right now? You know, like a much more complete picture than you used to see. Well, that is an illusion. Okay, I arbitrarily selected which facts I was going to present. I gave you a very narrow number of species. A huge amount of your opinion right now is based off mahogany, one tree that accounts for a very small percentage. But I didn't tell you what percentage of logging in the tropics was done from mahogany. However, you'll find that example, especially since it's a learning objective, will guide a lot of your thinking. One tree will guide a lot of your thinking about this, except that I pointed it out to you. So now you're starting to see that you've been manipulated. Not like negatively manipulated. I was just trying to tell a story that would stick with you, right? And learning objectives that you could hold on to. I had to make it all make sense, kind of like news stories. Okay, anytime you are listening to the news or reading some kind of post on social media or on any website that's talking about scientific facts, you'll notice they don't quote many facts. They'll quote like 12 total, detailed data facts, but it'll be a 500-word piece. So less than a tenth of it will be facts. The rest will be interpretation. Okay, so I'm not saying one side. I'm not choosing a side in this. I'm telling you that every time you look at a news story that's got science in it, if you find it interesting in the way that it's presented, that means it's misleading. Okay, I want to say that clearly. Interesting science in the news, in popular media, is misleading science. The more boring the science is, the more factual, the more words it takes them to describe what that one number truly means and all the assumptions behind the number, that's the closer you are to an actual fact. So, the only way to defend against this is to, number one, don't hold super strong opinions based on science you learned from a newspaper. Okay? Honestly, science is very hard to understand and it's very complicated, and what we do as science fact is very far from the interpreted cultural needs of humanity and the ecosystem. Okay? So this is how some people can seem hostile towards science without being hostile towards science. Okay? You can be hostile towards an interpretation while still acknowledging a fact. All right? So point number one, be careful how far you commit to conclusions. Number two, you should always be reading multiple sources that don't sound the same, that don't have the same agenda. I like to use the CNN, Fox News, MSNBC rule. If you're watching Fox News, CNN, and MSNBC, and they're all saying the same thing, you're probably listening to a fact. All right, and that's something you can probably trust. If they're saying opposite things, both of them are interpreting it, and you don't know which side, if any, is actually a true interpretation. So be very careful how much confidence you have when you walk away from one of these complicated topics, because I've shown you how easy it is to flip you back and forth with small amounts of information. And now also damaged my credibility as an instructor. Great job, Dr. Lockamy. Maybe you should have left him with something positive. Crap. Should have like a comic strip here or some cheeky music to come along. Maybe that'd help. I don't know. Maybe I'll do that in post-production. Who can say? All right. Talk to you later. Bye.